I'm Francis Levy. Ed Necessian and I are co-directors of Philocteti Center. And welcome to Mathematics. And I'm giving you a chance to recapture your composure. and religion. My time sense is changing due to all this talk about math. And speaking of which, we are having a panel on time. So that is, those of you interested in mathematics, we are having a panel on time that will be moderated by Mark Norell from the Museum of Natural History, who's been with us on other panels, and that will be coming later in the year. Before we begin today's program, I wanted to again call your attention to the exhibit on the walls, which is the mathematics and the aesthetics of mathematics, which was curated by Hallie Cohn and Adam Ludwig, and it features work by Sarah Ferguson. That's the head you see outside with the math all over it. Harish Lavani, the work in front of me. Devon Powers and Joan Waltermath. A lot of times people come to the room and they don't realize that the exhibit is related to the roundtables. And in this case, it relates to two roundtables, the mathematics and religion that we're doing today, and math and beauty, which is coming later in November. And both of these, by the way, have been funded by the Templeton Foundation, and we express our gratitude to Templeton for funding these particular activities. Again, those of you who've heard me before, we need your help. We have gotten some funding, as you know. We're proud of the funding we've gotten from Bloomberg LLC, from the Department of Cultural Affairs. But in order to stay alive past December 31st, and that's what we're struggling with now, we need both patronage and help on an individual basis. We've put out a little jar outside in addition, so if those of you who have the urge to make a small contribution or any contribution can put that contribution in the jar. Now I'm pleased to present Rebecca Newberger Goldstein. Rebecca Newberger Goldstein is a novelist and philosopher. She is the author of 8 books, 6 of them fiction, including the best-selling The Mind-Body Problem. Her last 2 books have been nonfiction: Incompleteness, The Proof and Paradox of Kurt Gödel, which was chosen by Discover Magazine, the Chicago Tribune, and the New York Sun as one of the best books of 2005, and Betraying Spinoza, The Renegade Jew Who Gave Us Modernity, which won the 2006 Koret International Award for Jewish Thought. The recipient of numerous awards for scholarships in fiction, she received a MacArthur Genius Award in 1996. And I didn't need to know she'd gotten a MacArthur to know that she's a genius, because we were talking on the way over here. At a certain point in the conversation, I was with her, and then at another point, I knew it was making a lot of sense, but that I couldn't follow it any longer. It was about the part about your PhD thesis on hard consciousness, and in recognition for her talent for dramatizing. This was what the award was for. She got the award for dramatizing the concerns of philosophy without sacrificing the demands of imaginative storytelling. Her newest book is entitled 36 Arguments for the Existence of God, a Work of Fiction. Good. There, you see what I mean? And will be published by Pantheon in 2009. She is a research associate at Harvard University. Dr. Goldstein will moderate this afternoon's panel and introduce our other distinguished guests. And I've been told to remind everybody, those of you who come here, that we do, our audience does participate, but we will let you know when that's to be. And then when you do come up to have a question or make a comment, use the microphone. Thank you very much. And please turn off your cell phones.
Thank you very much. Is this working?
Yep.
Yes, good. Thank you. Thank you so much for inviting me and for organizing such wonderful meetings of the minds. And may you continue your amazing work. It's my pleasure to introduce this distinguished mind gathering. And to my right is Professor Dominic Balestra, who is a philosopher, former chair of the philosophy department at Fordham, also the former dean of the arts and sciences faculty at Fordham University. And he is the author of many articles, has given many talks, many of them directed toward the juncture between science and religion, philosophy and religion. I hope that is a fair description. And to his right is Mac Tegmark, who is a physicist and metaphysician, I would say as well. He is an associate professor at M.I.T. He's previously taught at the University of Pennsylvania, served as a Hubble Fellow, and he's somebody who I've been trying very hard to talk into writing a book because I think his ideas, as you're going to see today, really deserve a full-length book. Am I supposed to introduce?
No.
No, okay. Leave you out. Well, then it is my pleasure to introduce Professor Loren Graham, who is a professor of the history of science, emeritus at MIT, currently an associate researcher at Harvard University. And those of you who were here this morning had the pleasure of hearing him give a talk on his latest book, Naming Infinity. I'm sure we're going to be talking about telling a fascinating story of the intersection between mysticism and mathematical creativity. And to my left is Professor Edward Nelson, a very distinguished mathematician at Princeton, winner of the American Mathematical Society Steele Prize for seminal contributions to research. And I only recently learned from what I was given, has spoken at the Vatican, giving a talk on mathematics and faith. So certainly we have here a novelist, and a philosopher, physicist, historian of science, and a mathematician. And we're going to talk about not science and religion that has been spoken about so much recently. We're going to talk about mathematics and religion, which has not received as much attention, I think. And we want to see if there's anything that these two fields, disciplines, questions, sets of questions have in common. And I thought I would just set the stage by talking a little bit about, well, why would you think that they have anything in common? It's much more natural to think they've got nothing in common, mathematics and religion. Mathematics it's our clearest domain of human knowledge. It's the one place where we have certainty. It's the one, it would seem, that's the way we think about it. It's the one place where we have proofs. And these proofs, when you prove something in mathematics, it's immune to revision. It doesn't matter what empirically, unlike physics or cosmology, it doesn't matter what we empirically observe of the world. We are never going to discover that 5 plus 7 doesn't equal 12. If I count 5 things and 7 things, and I come up with 13 things, I recount. And if I keep getting 13, I think, well, some kind of splitting has taken place. Or I'm dreaming. Or even I'm going mad. But no experience is going to cause me to take back the belief that 5 plus 7 equals 12. And much more interesting mathematical results as well. Nothing that we could observe, it's certain, it's immune, and we know it with great clarity and penetration. Unlike our knowledge of God, if there is such a thing, or our beliefs in God, if ever there is a place where there's uncertainty and people have intuitions, and their intuitions can't possibly be right because people with very certain intuitions disagree with one another and kill each other because of their very certain intuitions. If there's one place where we think we know, you can't trust intuitions, it's on the subject of God and religion. So why would one even think that mathematics and religion have anything to do with one another? They feel so different, it seems, on the surface. Mathematics, however, is very, very certain. But there are a lot of questions about mathematics, what we call meta-mathematical questions, which are completely uncertain, including what is it that we're doing when we do mathematics? What is it that we're knowing? Are we discovering? Are we creating? Are we making up the rules as we go along as a higher form of chess? Or is it some kind of real objective discovery? And that means if it's not discovery of this world, because although it describes this world, it can't be empirically invalidated by this world? Is it of another world, of a super-sensible world, a transcendent world? And so you see how these questions about mathematics and questions about super-sensible, transcendent God might possibly have something to do with one another. Also, mathematics often, although it proceeds by proofs are often the afterthought. It's after you've already seen it. You have a heuristic grasp of it. And then, again, if this is a transcendent world, what are we seeing when we're seeing these things? And how are we making contact with this transcendent world? So there is, although mathematics itself seems very, very certain, mathematics raises all sorts of questions about human knowledge and the limits of human knowledge and how we can do what we do when we're doing mathematics. So that is a little bit of, to seed in a little bit of uncertainty about mathematics and knowledge of mathematics that might have something or other to do with issues of God. Certainly have been claimed to. So that's a little stage setting for why mathematics and religion might come together in a discussion. And what I would like to do now is, I guess, Loren Graham was very, very honest this morning, and he kind of just laid it on the table what his view is of the God issue, and also, I guess, maybe even a little bit of mathematical truth. So it would be interesting, I thought, for all of us to go around and to start off the discussion and say, first of all, if you have a view about mathematical truth, do you think that it's objective and independent, or a kind of we make up our formal systems and we crank out the results? And what your view is on God, and do you think that there is, in fact, any intersection between your two views? Are you influenced in any way, one way or the other, on these two issues? So, Dominic.
Wow, that's a large order. My views on mathematics and my views on God. Wow.
And then there'll be no secrets from any of us.
Well, on the mathematics thing, area, there are three, I might say, though there's a little more now. At the turn of the 20th century, entering it, there were like three schools of thought. The Platonist, where you believe there are these mathematical entities that are non-physical, non-empirical, eternal objects, if you will. They're there, and the mathematician, when the mathematician comes to know them or know truths about them, he or she is dealing with this world that transcends, in some sense, the physical world. And that goes back to Plato, who said it so well. Then another approach are the formalists, who reject that completely and want to say all mathematics is about is syntax, these symbols that they're manipulating, and there are rules of syntax. It's about logical proof, conjecture a theorem, and then you logically prove it. Usually you work from a system of axioms, like in Euclid's geometry, and then you prove theorems that follow using well-established logical rules of inference. Now what's interesting is, now I'm going to maybe pose a question to what you said. What's interesting, though, is in mathematics, we know now you can prove theorems in geometry that contradict what you can prove in Euclidean geometry. And we know that non-Euclidean geometries emerged. And so which raises interesting questions about the creativity question. And maybe that's what part of the meaning of the freedom of the mathematician, what Gödel talked about, is there is a certain freedom there, a certain freedom, a certain play, where if you can make that right move, it opens up a whole new world. So those mathematicians who were working on what they were trying to do was a indirect proof of the fifth postulate of Euclid, the parallel postulate. And they couldn't derive a contradiction by negating it and joining it with the others. So they started generating all these interesting results, and I guess someone finally realized hey, you know, this is an alternative geometry. It's opened up a whole nother, you might say, world of space. And so you say, now, are they in contradiction? Well, yes and no. And I'm going on and on here. But so that's the formalist maybe could play with that and have some fun. You have the Platonist. And then there's that third view. I guess they were called the intuitionist, which is a strange name for them, but really comes from Kant, the philosopher. And it had to do with Kant's view of mathematics, which was, I think, another word for the intuitionist view of math, is the mathematical entity that's known by the mathematician is constructed in the mind of the mathematician. And it's constructivism. But what is it? What's the material of the construction? What is it that the mathematician is constructing, shaping, forming? Now, for Kant, it had to do with the forms of a very transcendental theory of Kant, but it had to do with an idealism, the forms of space and time internally to the mind, the human mind, something like that. So those are the three views. There's some. I have to confess, I lean toward Plato, partly because of Gödel's proof. He showed that there's more mathematics than we can prove, something like that. That's very crudely said. But also, I think I lean that way because in the end of the day, Plato's my philosopher. And a remark was made during in response to the lecture this morning about by Whitehead, but it really goes back to Plato. Is this mathematics that we do a kind of divine madness? I'm not a Platonic scholar. And I don't know Plato that well, but I know him well enough to hazard this. What you find in Plato is he pushes the boundaries of reason, rationality, intelligence, as we understand it, to where it can no longer answer the question. And he characteristically, when he pushes it there, turns to myth. And it's the mythic where the divine, if you will, resides. And this capacity that humans have to do mathematics in such a creative way, Plato's suggesting, it is something of a divine gift. We can't account for it and explain how it comes about, but we have it. And that's the divine element in us. Now, what I'd like to do, but I'll stop here maybe in the discussion, I'd like to connect that with Spinoza. And there's something like that runs in Spinoza. Now, it won't give you a personal God, I don't think. Is it compatible with religions that have a more personal God? I think that's a very large question, and I don't know enough sophisticated theology to puzzle that out. Because theology, when it's done well, is sophisticated and very nuanced and not easy. But and I still haven't come clean on, am I a theist? Yeah. I'm a practicing Catholic. Probably a heretical one, if you really ask me what all the things I believe. But that's where I come from.
So, Rebecca, you asked us to start off by talking about our own views or guesses as to both what's going on with mathematics and with religion. To me, these two questions are really the same question. And you're asking, what do we believe about the ultimate nature of reality? And this is, I think, the basic question which really gets me fired up about life. I feel so lucky to have a job where I get to spend a lot of my time thinking about the ultimate nature of reality, and that they even pay me for it is a scam. I hope my department chair isn't watching this on webcam. In terms of the three views which you nicely summarized there, Platonist, formalist, and intuitionist, I'm very much a Platonist, and perhaps the most extreme Platonist that I've come across. It's so extreme, in fact, that I think I belong to a minority of one among my physics colleagues, at least, where I have this very heretical view that physical reality and mathematical reality are actually one and the same. If you go back in history, already Galileo exclaimed that nature is a book written in the language of mathematics, and he didn't explain why, but he noted that many of the regularities can be captured very nicely in this language. And since then, we've seen there's more and more mathematical regularities cropping up around us. After relativity theory and quantum mechanics had come along, which are very mathematical, Eugene Wigner wrote this beautiful essay in the 60s on the unreasonable effectiveness of mathematics in the natural sciences, where he felt that this was such a striking success that it really called out for some kind of explanation. He again didn't really give one, but my guess is that the explanation is that reality is so well described by mathematics because it is ultimately purely mathematical, and not only is our physical world described by a mathematical structure, but it is a mathematical structure. So I think we're all living in a gigantic mathematical object, not one of the simple ones that we learn about in high school math. And we're not living inside of a cube or a dodecahedron or in the set of integers, but there's some more complicated mathematical object, maybe M theory, maybe more likely something we haven't discovered yet, which somehow is our reality. This is my personal guess as to what's going on. But I try to keep a very open mind. I think humility is very much in order when speculating about these big questions. And I think if I had to summarize everything I feel I've learned that I'm really convinced about so far from my life in science, I think I would summarize it by saying that I'm really convinced that the ultimate nature of reality, whatever it is very different from the way it first seems.
Well, as I said this morning, I am a secularist. What? I am a secularist. That is to say, I am not religious. However, I just wrote a book which is about how religion helped mathematics in a particular instance. As a secularist, I'm not too persuaded by most arguments linking science and religion. I find arguments coming out of physics and biology and chemistry linking science to religion weak and contingent. I'd like to think that I'm tolerant enough and big enough to hear those arguments and to recognize that very important people have been moved by them. I don't dismiss them. I'm just saying that I do not find them personally very persuasive. But I would sort of go almost against something that Rebecca said, although she didn't assert it, she just portrayed this, and say that of all the arguments linking science, if you want to include mathematics, to religion, the ones that I find the most interesting, I'm not going to quite say persuasive, but the ones I find the most interesting are in mathematics. There are non-trivial arguments, in my opinion, in mathematics linking it to religious concepts. I think it has to do with the fact that, as Hermann Weyl said, some mathematicians say that mathematics is the study of infinity. And once you start thinking about infinity, the supposed links to religion get rather obvious. God is supposed to be of infinite quality, omnipotent, and so forth. Many of the adjectives that one uses to explain divinity are strikingly similar to adjectives that we use to explain mathematical infinity. And many people have been moved by this. And some of them are important mathematicians. Nicholas of Cusa, Hermann Weyl, Arthur Stanley Eddington, and my Russian, if I can say that, Russian mathematicians, Nicholas Luzin and Dmitry Yegorov. The arguments that they use to talk about infinity and types of infinity and names for God and names for divinity are, in my opinion, not trivial. They're worthy of consideration. I tried to lay them out in my book. One of my graduate students heard about the book and came up and he said, "Loren, you're not going mystical on me, are you?" And there are people who think that anyone who gave a sympathetic account, as I hope I gave, to these religious mystics and their work on mathematics, if you think that means I'm sort of halfway in their camp, I would say no, but I appreciate them, I understand them, I'm thrilled by them, I share their aspirations. I'm not, at the end, quite persuaded. George Cantor taught us that there are different types of infinities, even in mathematics. Countable infinities, non-countable infinities, and lots of other kinds of infinities. Well, just like there are different kinds of infinities in mathematics, in my opinion, there are different kinds of infinities outside of mathematics. And therefore, it isn't obvious to me that when we speak of God or a divinity in terms of omnipotence or other infinite qualities, that infinity is the same as infinity in mathematics, and therefore they can be equated or linked or made a strong bond. I have serious doubts about that. But I still would like to pay a compliment to these distinguished mathematicians who have made the argument that they have a mystical intuition that is linked to their belief in God that helps them when they do mathematical work. That can't be dismissed. It's a historical fact.
Well, we have a wide spectrum in this panel. I'm an extreme formalist.
Yes.
And the interesting thing about the three schools of thought about the foundations of mathematics is that it doesn't make any difference when it comes to the practice of mathematics. Mathematicians who think about foundations might describe themselves with one of these three terms, but we all agree as to whether mathematics is correct or not after it's been sufficiently studied. And this is really remarkable when you think about it. What other discipline, what other field of human endeavor has this extraordinary consensus over time and space as to whether something is correctly proved or not?
Physics, maybe.
Oh.
You can have people with very different metaphysical beliefs about what's going on, but if the experiment shows that this theory is wrong...
Once you come to the experiment, but in terms of theory, I mean, the divergent views on whether string theory is correct physics or not, that doesn't happen in mathematics.
Okay.
But the foundations of quantum mechanics, I mean, you have these people who have extremely different interpretations of what's going on in quantum mechanics, but they all work together and apply the theory. So would you accept that happens in physics?
No, I think there's a qualitative difference in mathematics, that the consensus is really, truly remarkable and unique. It's my own feeling.
But on a positive note, I think this diversity in philosophical views that we see both within physics and math are really a strength rather than a weakness of our communities. Because if we had some kind of Microsoft monoculture in terms of ontology, right, where everybody believed the same thing, that would mean that everybody was excited about doing exactly the same kind of research.
I agree.
And everybody would be looking under the same lamppost. And precisely because different people are passionate about doing very different things, we get so much more diversity, and we find some things which really work out, and it makes us much stronger as a community. So I never feel compelled to try to convince someone who believes other than myself, to think my way, because I think it's much healthier to have this range of views.
Another interesting feature of mathematics is the tremendous time frame. In ancient Greece, people worried about or thought about the nature of perfect numbers. 6 is called a perfect number because it's the sum of its divisors other than itself. 1 and 2 and 3 divide 6. 1 plus 2 plus 3 equals 6. And Euclid not only did geometry but did number theory in his book, and he proved that numbers of a certain form connected with prime numbers were perfect. And so yes, it was 2,000 years later, in the 18th century, Euler proved that every even perfect number was of Euclid's form. That's a tremendous time frame to be working on the same problem. And it's an major open problem today. Do there exist odd perfect numbers? No one knows. Now, I describe myself as an extreme formalist. That means that David Hilbert, who's regarded as the founder of formalism, I think was in his heart a Platonist. He, I believe, adopted formalism as a strategy against his antagonist, the intuitionist L.E.J. Brouwer. And, for example, he set the program of proving that mathematics was consistent, starting with the number theory, to prove that number theory was consistent. Well, that's a mistake. The question is elementary number theory consistent or not? I believe it's not. I believe that we do not have certainty in mathematics. I believe that many of the things we regard as being established in mathematics will be overthrown. I'm a crackpot in that respect.
Just to clarify, do you believe that one day someone might actually prove within number theory axioms that 0 equals 1, so that everything would just come crashing down?
Yes, that's what I'm working on.
What does that mean you're working on it, just like for a layperson? How do you work on it?
That I'm keeping to myself for the time being. Give me 2 years.
I just can't wait to see Rebecca's expression when you prove for her that therefore 5 plus 7
Well, that means
equals
there's something
13.
wrong with the axioms, not there's something wrong with 7 plus 5.
Yeah.
So, but as I said before, mathematicians of all schools of thought agree as to whether something is deduced correctly from the axioms. The question is whether the axioms are consistent or not. Now, in terms of religion, I'm a Christian. Worship and prayer are very important to me. I experience religion more as a matter of faith than of a belief system. And I think there's one question where mathematics and monotheistic faith seemingly conflict, and that is in the nature of mathematical objects. Let's take the numbers, 1, 2, 3, 4, 5, and so forth, 0, 2. But also more general mathematical objects like exotic spheres and whatnot. Do these things exist? Well, as a formalist, I believe that we make them. But if we believe that the numbers 0, 1, 2, 3, 4 exist as a completed infinity, where did they come from? Have they existed as they were in the beginning, or now, and never shall be? That sounds like a religious belief, not mine. If we believe they're created, that raises a problem, because I believe it's part of monotheistic faith that all of creation is contingent. It could have been created otherwise. How could the numbers have been created otherwise? I think there's a real problem here.
Okay, so I'm going to spill my guts too, which is I'm a reluctant or a skeptical Platonist. I wish I weren't a Platonist. It's too mystical for me. I don't like it. But I think, for example, there's a famous unsolved problem, Goldbach's conjecture, every even number is the sum of 2 prime numbers. Hasn't been proved false. If it is false, then in principle, one can show it. One just has to keep going far enough, and you'll come to the counterexample. If it's true, we may never know. There may never be a proof that gets us to it, but I think it has an answer. I think Goldbach's conjecture is either right or wrong. Every even number is the sum of 2 prime numbers, or it isn't. That makes me a Platonist. And I can't make my way around it. I also found I started studying Gödel's incompleteness theorems when I was a graduate student, hoping that it wouldn't somehow seem to point the way to Platonism as he thought it did. And I think it does. And I don't like it. That's not my orientation. Until somebody, perhaps you, can show me how we dance around, how we get around Gödel's incompleteness theorems, I'm going to feel going to have to give it some credence, Platonism. And I am an atheist. I am not wishy-washy on this question. I not only do I think the arguments for God's existence don't work, I think that this, more importantly to me, does not look like the kind of world, empirically, that is created by a good and caring and powerful God. It just, to me, there's just too much empirical evidence against it. Suffering of children is my number one complaint. And the amount of work that one has to do, that philosophers have done, that theists have done, to answer the question of the problem of evil, free will, and that works for only some of them, and the Holocaust was okay. The Nazis had to have the power to absolute evil in order for them to be free, so a certain amount of suffering had to take place. But even that only goes so far. There's a lot of suffering that can't be answered that way. Soul making, this is a place where a lot of virtues can only be induced. We can only come to them because of suffering. That doesn't really seem to me to explain the suffering of children. Anyway, to me, this just doesn't look like a world created by God, and so I am an atheist. I'm not an agnostic, I'm an atheist.
Why must God be a producer only of good things? Your definition seems to presuppose the notion of goodness.
Well, yeah, it's absolutely right. So the God that I would want to, sort of pray to and care about and that sort of thing, I don't see this as that kind of God. Yeah, any other thing you want to call God. I'm written a book on Spinoza, and I suppose, depends what you mean by Spinozist, but I would define myself as a Spinozist. I do believe in Spinoza's notion of God, which is a non-transcendent God. Right. The world itself is God. Understanding the world, I guess you will disagree with me.
That's not Spinoza.
Well, that's the thing.
Mistaken reading of Spinoza.
Well, we can argue about that.
I could give you the place in Book 1 of the Ethics where it stands out.
Tell me.
What he says there, he talks about God, and then and I want to link Spinoza. It's not unrelated, I think, to what you said about 0 and 1. This is very broadly. Spinoza, to Plato, to Parmenides.
Yeah.
Parmenides, some of you may know, you may not. Pre-Socratic, early dawning of what we call philosophy in the West is this Parmenides, this thinker. There's Thales and others, but Parmenides to me is the one who nails it. Because he's the one who starts separating what we think of, what emerges as rational thinking as distinct from mythic-like thinking. Or a thinking that has it all undifferentiated, the 0 and the 1s. And then you start seeing it differentiating. And Parmenides then says, reflects on this, that great fragment we have from him, but basically says, look, ultimately, anything, and he refers in an indefinite pronoun to it is or it is not. And he says, if it is and cannot not be. In other words, and then he says, and it is not, cannot be, and is unthinkable. And then he, stresses this. Now there are critiques later in philosophy where he's confusing the predicative use of the is with the identity use and the assertive to be use and all that. But when you come clean on it, and this continues in philosophy, what he's saying is the question of being kind of gradually emerges. Think it is or it is not. And then he suggests, and this is what the tough challenge is, it is must necessarily be, and it is not cannot be, and it's not. Then he says there's another alternative that many think is thinkable. And he's saying this is a way that's confusing, it's mere opinion, and false. That it is and is not. And that's what all the particularity of the world is about. I am, but I'm not you. You are, but you're not me. Each of us is, but we're not the it that is. or God, if you want to use that name. And then you see the struggle of working that out. Plato directly deals with that. In Spinoza, he's the modern-day Parmenides. He says anything that is can only be in and through itself or in and through another. And stress on another. Now, if the things we think exist, we identify them, all the ordinary things of everyday life, and you, me, the cup on the table, that thing exists either in and of itself or in and through another, by virtue of another. And you have to cut clean on it. And what he does is he argues in that first book of the Ethics, it all has to go back to that it, the one being, use God as the name, that is in and of itself. And anything else that has its being has it through that. Now, most people, or many, will read Spinoza saying God or nature. God is nature. He identifies God with the world and everything. You read him more carefully in Book 1. He says, God is that being that's a substance, an infinite substance. And as an infinite substance, God has an infinity of attributes, each of which attribute is infinite, of which we only know 2 or 3 attributes: mind or thought, extension, and then I guess existence would be in there. But it's clear he's saying, but God has an infinity of attributes beyond our knowing. And then if you take Spinoza's explanation of knowing, human knowing, your knowing or mine, is perspectival. It's from a perspective, which means it's limited. And implied in Spinoza, and I think you could really carefully read his Ethics and show it, there is more than you or I or all of us together can know.
How do you know that there isn't more to nature herself than you and I can know as well?
Oh, no, he would not deny that. But what he would deny, I think, is what Rebecca said. If you're going to say...
No, you didn't let me finish.
Okay.
You didn't let me finish.
Sorry.
Totally miss what I was trying to say about Spinoza.
I'm sorry.
Yes.
Go ahead.
Certainly, Spinoza's notion of both God and nature are completely different from what we think of as nature. Once, when Einstein was asked if he believed in God, and he said, I believe in Spinoza's God, what he was saying, here is what Spinoza, I believe, says, not as metaphysical, and it's what Leibniz, his younger contemporary, later called the principle of sufficient reason. It starts with a very simple question. Does every fact about the universe have an explanation? Is there always, and what Leibniz asserted is, yes, it does. It's a principle of reason that explanation goes all the way down. It's not turtles all the way down. It's explanations all the way down. There's no brute contingency in the world, so that there is always an explanation for everything. And ultimately, what that leads to is that the world is necessary. It necessarily exists. The world has to, the true full conception of nature, which is not attainable to us because we are limited to the 2 attributes, thinking and extension. So there's a kind of incompleteness theorem implicit in Spinoza's view. But the world itself, if we were to have the complete picture of it, image of it, which only God can have because it's infinite, it is in fact the infinite intellect of God, would explain itself. So transcendence, what he proves, if he's correct, is that the notion of a transcendent God is impossible. If, in fact, there is explanation all the way down, the world itself, the complete image of what nature is, if we had the final theory of everything, the final theory of everything would not only explain all the laws of nature, it would explain why these have to be the laws of nature. So when Stephen Hawking ends at the end of Brief History of Time, he says, then we would know the mind of God. This is straight Spinoza talking. This is a real Spinoza. The full picture, the full mathematics, if you will, of the final theory of everything will explain itself. So, that is, I think, what Spinoza is saying, and that is, I guess, kind of one of my only faith, is that it seems to me a reasonable assumption of rationality, that it's rational all the way down, that the universe always has answers, and if that's the case, the universe does end up, we'll never get there, explaining itself. And so that, but in the notion of a transcendent God, that's the one that I completely reject. Yes.
Is the conatus, or I mean, I always misinterpret this. Is that explained also? What I was told to be the demiurge almost, or
the conatus is something in us. It is. So then he goes on. I mean, one of the reasons that Spinoza was. I don't want this to turn into a Spinoza. I know you already had a Spinoza forum, yeah. But he was vilified, excommunicated by his own Jewish community, and then excoriated by greater Christian Europe, including Leibniz, who got some of his best ideas from him. So, coward Leibniz. But one of the things that he tried to do, which was so heretical, was to say not only do we need some sort of transcendent God to explain why is there something rather than nothing, one of the prime motives for a belief in a transcendent God, but we don't need God to derive ethics. His magnum opus is called the Ethics. And so he says that ultimately the answers for why is there something rather than nothing would come from a full picture of nature. And the answer of what is the difference between right and wrong and how ought we to act and what should be the ends of human life comes ultimately from human nature. And that's what he attempts to do. And conatus is a fundamental view of what is it that motivates human nature. It is the urge to persist in one's own being and to flourish. And from that, he tries to derive all of ethics. So he took away from what he called the superstitious religions the explanation for why is there something rather than nothing and what's the difference between right and wrong, and was hence considered a very, very dangerous man well into the Age of Enlightenment.
I think this is fascinating, actually, if we connect it back with what Edward Nelson said about how in mathematics you can have something that happens 2,000 years ago and then gets picked up again and new progress gets made. This very question, as you know, has come very much at the forefront of physics in the last few years, where we're in the middle of this very agonizing paradigm shift that makes most of my colleagues foam at the mouth about whether there will be these brute, unexplainable facts or not. So for example, Johannes Kepler, and when he revolutionized the understanding of our solar system, he thought he had this model where he tried to predict exactly the sizes of the orbits of the different planets, and he would probably be happy if we now today could predict the number 8 from first principles. Why are there 8 planets in our solar system? Sorry, Pluto. No, and
Pluto was excommunicated, I thought.
Yeah, but so in company with Spinoza, I guess. But now so of course now this sounds like a really ridiculous question. Why are there 8 planets? Because the number 8 doesn't tell us anything fundamental about our universe. It just tells us something about our address. We now know over 300 other solar systems. Yeah. Some of them have 8 planets, some of them have 2 planets, some of them have 3, So 8, the number 8, if we had tried to have an explanation from first principle for where the 8 comes from, we would just have been tilting a windmill looking for something which an explanation for something which fundamentally would be ridiculous to look for a fundamental explanation for. And what's happening now is that exact same demotion that happened to the number 8 is happening to almost everything that we used to call basic laws of physics. Like we ask, why are there 1, 2, 3 dimensions of space? Why are there 6 quarks rather than 9 quarks or 8 quarks? Where, to the best of our understanding, the way it seems now is that actually our universe is much larger than we thought. It goes on vastly beyond the part that we can see. And if you go sufficiently far away, you'll come to a place where there are in fact 8 quarks. So the number 6 is also just like the number 8. It's just this number 6 for the quarks, just telling us about our address in this larger reality. So you look at these numbers, and then in the end you realize this was just my telephone number. It wasn't something ultimately really fundamental. And so I don't know if Spinoza would be happy about this, in that it seems like maybe you can have a theory which requires no contingencies, or if you would be disappointed that this ultimate theory that we maybe we'll be finding actually is just telling us that the ultimate reality, physical reality, is so big that all the things we thought were facts were just part of our phone number,
as a
our
sort
address.
of extreme Platonist, seem implicitly to agree with Spinoza that the big picture, which is inaccessible to us. To me, it's amazing that we know anything at all.
It's remarkable.
It's remarkable.
Yeah.
We're just these random products of evolution. It's amazing we know
we
anything.
evolved our brains to be able to pick bananas and throw rocks at each other, and here we are talking about Spinoza.
Exactly. Right. But your intuition somehow also seems to be that, this big, extreme Platonist picture, the ultimate reality is mathematics that explains itself. You would seem your intuitions would be going that way.
I agree. If we look at the historical progression, we've again and again made the mistake as humans to assume that our universe was smaller than it really was. We underestimated the size of Earth. We underestimated the size of our solar system, our galaxy, and beyond. And much like ostriches who put their head in the sand, we figured that if you can't see it, it just ain't there. So if you ask, how far could this expansion of horizons go? What's the largest reality or multiverse that there possibly could be? Then that this Platonic multiverse of all possible mathematical structures, all possible laws of physics, as you might call it, it's sort of the extreme case that it could be. And I find that if you think about that, first of all, it's very dizzying, of course, but the second, I think it gives us some fresh air and sheds some new light on some ways of thinking about stuff. Like you asked, for example, a very interesting question there. The integers, were they created or have they always existed? Now, that whole question presupposes the existence of time, because you need time to be able for something to first not exist and then exist, right? A creation event requires time. But we know, Einstein taught us that there are two ways in which we can think of time. We can think of either as reality being this three-dimensional place where stuff happens over time, or we can think of us living in this four-dimensional space-time, four-dimensional space where the fourth dimension has a minus sign in it, which makes it feel like a time. And the space-time of Einstein, of course, there's nothing happening in there. If life is a movie, then the space-time is like the entire DVD. It's all in there. And the DVD isn't changing, even though there's all sorts of drama unfolding in the play. And so if you think of our reality as a mathematical object which contains a space-time, then time exists within this mathematical structure rather than the mathematical structure existing in time. So in the Platonic world, I think nothing ever needs to be created. It would only need to be created if there was some sort of higher time.
Of course, not every physicist agrees with Einstein on this.
No, of course not. And I said I'm a minority of one, probably among my colleagues. So
Arthur Stanley Eddington, for example, said that he believed that becoming is really there in the physical world. And I think he's right, as opposed to Einstein.
Whereas I would say becoming is really there in our particular this corner of the Platonic world where we live, where there is this time dimension, and then there are other mathematical objects like the integers, which don't have any built-in time in them at all.
Oh, they were human creation, a story that human beings make up. That's my view of the integers.
So I have a great respect for formalism, and I think that's part of the power of mathematics, that we can describe things purely abstractly. But my guess as to what's going on is that even though that if you look at, suppose there's life somewhere else out there in space, in a faraway solar system, the beings who live there, integers might not be the first stuff that they start working on. They might study other formal systems and other structures. However, at some point they'll probably find it really useful to invent the integers for whatever their goals are. And when they do, they will agree that 5 plus 7 is 12 and discover exactly the same properties of the integers that we've discovered here. So that I think different beings will be they were all discovering the same mathematical Platonic landscape, but they start at different places. But eventually, with a sufficiently thorough explanation, we'll all find at least the same main boulevards and thoroughfares, all discover kind of the Broadway and the Times Square, even though historical accidents will determine that there are large parts that we never discovered over there in Brooklyn. And
it'll be really interesting to see when we meet some alien intelligences. My own hunch, I've absolutely no evidence for it, is that their mathematics would seem very, very weird to us.
Wouldn't Kant? Are you an opponent of Kant? I mean, wouldn't Kant say that the integers were not invented? That these were eternal laws?
I tried twice, once as a teenager and once as an adult, to read Kant, and I couldn't understand him either time, so I can't answer that.
Yeah, Loren.
Yes, well, as a historian of science, I'm very much impressed with the fact that in the history of mathematics there have been crucial turning points. Imaginary numbers, irrational numbers, transfinite numbers. These were all extremely reluctantly accepted. There was a lot of opposition to them, and we could have gone another way. So I kind of guess, my hunch is that if we find mathematics in another civilization, it will be, at least at first glance, quite different from ours. But I just want to return for a moment to the more general theme of mathematics and religion and science and religion. Most people who, or at least many people who raise this issue, relationship between them, want to know, do they favor each other or do they oppose each other? Are they compatible or are they incompatible? And I'd like to make the case that that's the wrong question. I think you have to look at the context. If someone asks me to give examples of when science and religion fell into conflict, it's easy. Galileo, Darwin, so forth. You know the stories. If someone asks me to tell stories about where science and religion favored each other, it's easy. It's in Newton. It's in Pascal. It's in my name worshippers in the book I just gave. On the other hand, if someone asks me to find examples of where atheism helped science, well, I can come up with them. It's in Early Studies of the Origin of Life by G.B.S. Haldane, by Alexander Oparin. It's in the development of Markov chains in mathematics, which was developed very specifically against a religious argument based on Markov's atheism. So I would say that mathematicians and scientists get their ideas, their inspirations, particularly in moments of crisis, from all sorts of different places. It can come from philosophy, it can come from religion, it might even come from art. Those inspirations might come from atheism, can come from all sorts of different places. So I think that we ask the wrong question if we do think that there's some kind of unique answer to whether or not science and mathematics, religion are compatible or incompatible. They're both. And there are many examples of each.
I'd like to come back to sufficient reason. I've heard people maintain vigorously that the principle of sufficient reason is incompatible with quantum mechanics. There is no reason why this nucleus decayed at this instance instead of another.
Yeah. Well, of course, the response to those who hold to the principle of sufficient reason is that is evidence that quantum mechanics is incomplete, and we have additional evidence that quantum mechanics is incomplete. It's incompatibility with
the other possibility
theory.
is that randomness and chance are a fundamental part of the universe we live in.
It could certainly
and
be
it seems
true.
to me the evidence for that's pretty strong.
Wait,
And if you ever were here, who down the Stanley Road in Princeton postulated the many worlds interpretation of quantum mechanics, he would have given yet a third answer. He would have said, well, we live in this larger space, this Hilbert space, and it did decay in some parts of this and it did not in others in his quantum multiverse. And again, if I write down, say, a bunch of zeros and ones which denote whether it did decay or didn't decay in successive experiments, that string of numbers is again just part of our address. Part of our address now in this Hilbert space. And the ultimate reality is perfectly well defined. So that would be again an argument that there are no, that if you call this a brute fact, it's just a brute fact in the same way that your zip code is a brute fact, but it's not at reality itself has anything arbitrary about it.
That's what philosophers call an indexical proposition. That is, one could think that there's something. I'm a very special person because I'm always here. Everybody else is always there. Look at me. I'm really very special. And of course, that can easily be argued away, right? It's just as an indexical proposition. It's the person who is stating it is always here, whoever that person is. Well, there might be something about randomness or something about the way things look because of our address in this particular part of the universe. And, if you... I actually, when often people say, what would Spinoza say about quantum mechanics, which seems to make randomness part of the universe. And I do think that Spinoza, it's hard to what would Spinoza say, but I think he quite liked the multiverse, right? And there is a place where he says all possibilities are realized, and that's the multiverse, basically.
I'm not sure about my sense is that there's a big difference between Spinoza and Leibniz. Because Leibniz is the one who opens up the possible worlds and takes them very seriously. I don't think there's possible worlds. At the end of the day, in Spinoza, there are no possible worlds. All possibilities turn out to be the necessity.
Exactly. There are no possible... Exactly. This world exists because it's the only possible world. Right. And world...
That's very different than a world of possible alternative.
Maybe
on
Leibniz
the other hand,
was the
then,
better
but if this world is so large that it contains within it all possibilities, then it's sort of a strange anticlimax, isn't it?
Yeah.
Or at least a unification of the two viewpoints.
Exactly.
But I want to come back to something Max said and something you said, and I don't know that it squares. You made a clear distinction that mathematics, the language in, one language that's used is mathematics is a priori knowledge. If you put it in that Kantian language. Now, is it analytic a priori or synthetic a priori?